This is Mr. Gilman. Today we're going to talk about stem and leaf plots. What a stem and leaf plot is a way to organize data. And as you can see, this is a stem and leaf plot. The leaves are the digits on the right side of the bar. So I'm going to say that the leaves are this part. Okay, the right hand side. And the stem are the digits on the left side of the bar. These are the stem numbers. And the way you can read this chart is that the numbers 19, 22, 25, 26, 27, 28, 29, 30, 34, 36, 37, 42, and so on, those are the numbers that are represented on the stem and leaf plot. These are actually the tens digits. And these are actually the ones digits. Okay? And together they make numbers. So 19, 22, 25, 26, and so on. And the biggest number is 62. The smallest number is 19. Everything else in the middle. Now, once again, these are the stem, the tens digits, and these are the leaves, the ones digits for today. And that's as many digits as we're going to go to. We're going to keep it in the teens and the tens. Before we get started, we need to know a few things. We need to know what an outlier is. Okay? An outlier is when there's a number that is way bigger than everything else or way smaller than everything else. It's not in with the rest of the data. Clusters are isolated groups of values. That means there's a lot of numbers just in one little area, or there's a lot of numbers in one span. Just more in one spot than there is spread out throughout the data. A gap is when there's a huge space in between values. So it might be from 1 to 100, and there might not be a number. There might be a number 50, and then the next 30 numbers are 91, 92, 93, 94, 95. But between that 50 and that 90, there's a big gap there, and that's what we need to identify. Large spaces between values. Okay? Just keep in mind the stem represents the tens and the leaves represent the ones. Okay, let's find the following. The least value. So once again, I have the same stem and leaf plot up here, and the way you can think about it is this is 19, 22, 25, 26, 27, 28, 29, 30, 34, 36, 37, and so on and so on and so on. Now, if I want to find the least value, it will have the smallest tens number. In this case, the smallest value is 19. The greatest value will have the biggest tens number. In this case, it'll be 62. Okay? Now, we need to look for outliers, numbers that are way above or way below. Now, in this case, we go from 19 as our lowest to 22. There's not much of a gap there. And then they're pretty well spread out evenly in the middle. And then 62 is the biggest, but it's not very far from 58. So I'm going to say there's really no outliers. There's no outliers this time. What about clusters? Is there any clusters? You could say that there's a cluster in the 40s. There's a ton of numbers in the 40s compared to the rest of the graph. You could say there's a cluster in the 40s. Usually there's only one or two clusters, but especially the 40s this time we have 1, 2, 3, 4, 5, 6, 7. 7 numbers in the 40s, and the next biggest is 6 in both the 20s and the 50s. I'm going to say that just the 40s is a cluster. There's a lot there. Okay. And as for the gaps, I'm not seeing any huge gaps that I need to take note of. Like I said, there's only a little difference here and a little difference here. So we're going to say there's no gaps in this stem and leaf plot. So there's none. Okay. So let's look at another one. And this time, there should be an example of everything here. Once again, okay, you have the tens and you have the ones digits, the stem and the leaves, and we need to find the least value. But this time, we started with the 90s on top and the tens on the bottom. So I'm going to say the smallest number is 16. The least value is 16. And I'm going to say that the greatest value is 96. So 96. And now I need to find some outliers. And remember, those are the ones that are way far away from the data. My biggest number is 96. It's not too far from 90, and it's not too far from 87, 83, 85, and those numbers. And we're pretty well distributed in here throughout the bulk of our data. However, we had the 16 way down here, and it's way far away from the next number. The next number is 35. So I could say that 16 would be an outlier. It's way far away from the data. It doesn't quite make sense. For clusters, I would probably consider the 60s to be a cluster. There's a ton of numbers in the 60s. It's way more than anywhere else. So I'm going to say the 60s are a cluster. And finally, the gaps. Now, we said that there's an outlier at 16. Usually with outliers come gaps. There's a big gap from 16 all the way up to 35. That's a gap of 19. So I'm going to say there's a gap from 16 to 35. There's a gap there. And so that's going to be my gap from 16 to 35. So I've identified all my values in this stem chart, the stem and leaf plot. So let's look at another one. Now we're going to make our own stem and leaf plot. So first we need to find the smallest and the greatest values, and we're going to write the stems in a column. Okay, any 10 digits we're going to need, we're going to write them in order, and we're going to put them in a plot. We're going to draw our vertical line, and then we're going to go through our data and start writing in our leaves. After we get our stems and leaves, we need to make sure all our data is in order. So we may have to draw a second stem and leaf plot to make it extremely accurate. So let's take a look. What I want to do is I want to organize all this data into a stem and leaf plot, and I want to find the least value, the greatest value, the outliers, the clusters, and the gaps. Now let me just make sure I don't have any numbers hidden over there. Okay. These are the ones that I want to use, this data. So what I need to do first is identify the smallest and the largest numbers. I think that 51 is going to be my smallest, and I'm going to say 93 is going to be my largest number. 93 is my largest, 51 is my smallest, just for the sake of getting my chart started. Now, if 50s is the lowest and 90s are the biggest, I'm going to need my 50s through 90s. So I'm going to say 5, 6, 7, 8, and 9 is what I'm going to need for my stems. Now I can go through my data and put in my leaves. 51 means I'm going to put a 1 near the 5. 73, I'm going to put a 3 near the 7. 79, I'm going to put a 9 next to the 3. And 90, I'm just putting in all my leaves here. And it's going to take me a little bit longer here to get everything in. Okay, and so I have my stem and leaf plot. However, it's not in order. I need to make all my numbers in order from least to greatest. So now that I have the stem and leaf plot, I want to write it more organized. 5, 6, 7, 8, and 9. And I want to put my numbers over here in this column in order from least to greatest. So instead of 1, 3, 9, 8, I'm going to put 1, 3, 8, 9. And in my 6s, I'm going to go 1, 4, 6, 6, 7, 7, 8. So I've got that one out of the way. I've got that one out of the way. And now my 7s. I'm going to say 1, there's no 2s, 3 3s, 2 6s, and a 9. So I've got my 7s done. Now my 8s. I'm going to say 1, 2, 6, 6, 7. That's in order. And now 0, 1, 3. The 9s are already in order. So now I need to find the following: the least, the greatest, the outliers, the clusters, and the gaps. I'm going to say my least value is at the top at 51. I'm going to write 51 in. And then I'm going to say the greatest value is 93. And we kind of already identified those out of our data. So that's good that they're on our stem and leaf plot in the same spot. Now I'm going to look for outliers. Is there any numbers that are way far away from everything else that don't really belong in the data set? In this case, I'm going to say 51 is the lowest, but it's right next to 53, so that one's okay. And 93 is the biggest, and it's right next to 91, so that's okay. So I'm going to say there's no outliers this time. I'm going to say there's none. And as for clusters, it looks like I have a couple clusters here. I have a cluster in the 6s, in the 60s, and a cluster in the 70s. So I'm going to say there's two clusters, the 60s and the 70s. Okay. Or I could even say more specifically, I have a cluster from 86 to 87 because I have three numbers in only two spots. But for now, that's fine. The clusters are more of an opinion more than anything. They will really be obvious when they're supposed to be clusters. And finally, I need to find the gaps. Is there any big gaps that really shouldn't be there? Because there's no outliers, we know that there's no numbers that are way far away, so I'm going to also say that there's no gaps. None.